Hello students, hope you are doing well. In this video, we are going to look at the remaining topics of gravitation, and the topics that we are going to look at are Kepler's laws of planetary motion, under which we will study about first law, second law and third law. First, let's look into the first law or law of orbits. Now, the first law or law of orbit says that every planet moves around Sun in an elliptical orbit with Sun as one of its foci. Now see, before Kepler, the general belief was that planets moves around Sun in circular orbit. After Kepler proved that every planet moves around Sun in elliptical orbit but not circular orbit. Of course, the ellipticity is not very high, and Sun is one of the foci. An ellipse has two foci, so Sun can be at any of the positions. So here you can see that this is if I take this as a planet, then this is Sun. So the first law talks about the shape of the orbit. So once again, what does the first law say? First law says that every planet moves around Sun in elliptical orbits with Sun as one of the foci. Then we move on to the second law. Now the second law talks about the speed of the planet in an indirect way. Now it says that a line joining the planet to the Sun sweeps equal areas in equal intervals of time. So if I join the planet with the Sun, and if I start with the motion of planet, if I start sweeping areas, then I see that it covers equal areas in equal intervals of time. Now what are the consequences of this law? Now the consequences of this law is, because when the Sun is closer, the line's length is less. So when the planet is closer to Sun, the line's length is less. And when the planet is away from the Sun, the line's length is more. So you can see that if I call this part as part 1 and this part as part 2, now part 2 area is equal to part 1 area. But if I look at the distance covered on the orbit, here the distance covered is this much. I'll call this as distance as L1, and here I'll call this distance as L2. I can see that L1 is greater than L2. Now because they are taking same time, I can say L1 by T is greater than L2 by T. So I can say V1 is greater than V2. That means what? A planet moves faster when it is closer to the Sun than when it is away from the Sun. So this is a very important consequence of the second law or law of areas, that a planet tends to move faster when it is closer to Sun than when it is away from the Sun. Now from where did we get this law? This law is an outcome of conservation of angular momentum. Now what does angular momentum say? Angular momentum L is given by mv into r. mvr is constant because there is no external torque acting on the system. The total angular momentum of the system is constant. So mvr is constant. If mvr is constant, we know m is constant. So m is mass of the planet does not change. So v into r is constant. That is product of velocity and the distance from the Sun is constant. So I can write v1 r1 equal to v2 r2. Or from this, what do I get? I get v1 equal to v2 r2 by r1. So that means if r2 is greater than if r2 by r1 is greater than 1, that is r2 is greater than 1, then v1 is greater than v2. That means if r1 is less, v1 is greater. Or if r2 is less, v2 is greater. Or a planet closer to the Sun moves with a greater speed. After that, we have law of periods. Now what does law of periods say? Law of periods says that square of time period of planets around Sun is directly proportional to the cube of semi-major axis of the elliptical orbit. Of course, in order to prove this law, we assume that the path is almost circular or the ellipticity is very less. So what does it say? It says that the square of time period, that is time taken by a planet to revolve around the Sun, is directly proportional to cube of semi-major axis. But if I take it as a radius, it is proportional to the radius of the path. Now when a planet is here, let's see what are the forces acting on it. I'll assume that the planet is here. The outward force acting on it is mv squared by r, and I'll take small r, the radius of the orbit, and inward force acting is gm mass of Earth by r square. So let's equate it. We get mv square by r equal to g. Me is mass of Earth, m mass of the planet by r square. So it's not mass of Earth, I'll say mass of Sun, because we're talking about planetary motion and planets are moving around Sun. So cancels, 1r cancels. We're left with v square equal to g ms by r. Now what is v? If I take the velocity to be constant, because if it is circular path, the velocity would be constant, the magnitude of velocity would be constant. It can be written as 2 pi r by t, the distance covered by time, where t is time period and r is the radius of the orbit, square equal to g mass of Sun by r. So this will give us 4 pi square r square by t square equal to g ms by r. So let's take all r terms to one side and all t terms to one side. I'll get 4 pi square into r cube equal to g ms into t square. Now we have 4 pi square is constant and gms is constant. From this, what do I get? I get r cube is proportional to t square, or t square is proportional to r cube. So this is what is the third law. Now this law can be applied to satellites moving around planets also, but I can apply this law to two satellites moving around same planet. I cannot apply this law to a satellite moving around Earth and another satellite moving around Jupiter. So for this law to be applicable, the central body should be same. If the central body, or about which the object is moving, changes, then this law is not applicable. So this is what is there in Kepler's laws of planetary motion. So let's have a quick review of what all things we have seen. We have seen Kepler's first law. Kepler's first law says that every planet revolves around Sun in elliptical orbit, with Sun as one of its foci. Because it talks about the shape of the orbit, we call it as law of orbits. Then the second law says that if I join Sun with the planet, Sun to the planet with a line, then that line covers or sweeps equal areas in equal interval of time. And one of the consequences of this is what? That a planet moves faster when it is closer to the Sun than when it is away from the Sun. And this is an outcome of conservation of angular momentum. And finally, the third law, or the law of periods, it says that square of the time period of planets around Sun is directly proportional to the cube of the semi-major axis. Hope you could follow this, and hope that you are watching all other videos of concepts and questions classified into level 1, level 2, level 3 according to the competitive exams that you are appearing, and making full use of this opportunity given by Get My Classes. Thank you very much, and keep watching concept and questions and solutions videos of Get My Class. Thank you once again.